Good afternoon, everybody, and thank you for joining us for today's webinar, Sense Making versus Answer Getting in Our Math Classroom. I just want to let you know that within 24 hours, everybody who participates in this webinar will receive a certificate for CEU verification. You will not receive it today, but tomorrow you will this time. Also, all resources from this webinar and previous webinars can be found on our Adult Educators repository. You can go to our website, and under our professional development, there's a direct link. Educate and Elevate. Adult education is an investment in America's future. About 80,000 legislative contacts have been made since April 2017. You can learn more at our website, educateandelevate.org. Mark your calendars for COABE's 2019 National Conference, March 31st through April 3rd, 2019 at the Marriott in New Orleans. There will be more than 30 strands to choose from, including Workforce Strand, CTE Strand, and the New Adult Learner Strand. Our Research to Practice, and this month our topic is numeracy. As part of our Research to Practice initiative, each webinar will help answer common questions about the adult educators have. This webinar will be helping to address the following question: how to encourage students to be independent learners. In our spring 2017 journal, Linda Ginsburg wrote an article, What's an Adult Numeracy Teacher to Teach? Negotiating the Complexity of Adult Numeracy Instruction. The COABE Journal aims to serve the needs of the adult education field and enables the field to share the research and best practices. You can learn more by going to our website and going to the Journal tab. This webinar is made possible with the support of Paxton Publishing. And with this, I'll turn it over to Jane Schultz.
Good afternoon, everyone. Paxton Publishing is one of the newest members of the COABE family, and we are very excited to be sponsoring today's webinar. Paxton Publishing purchased Spec-Bond Adult Education Solutions, and along with the great titles that you already are familiar with, we are introducing new materials to the adult education market. On the screen, you will find our website address and customer service number. Paxton Publishing is excited to bring TABE Tutor to support the new TABE 11 and 12 and Skills Tutor to the market in August of 2018. Next slide, please. If you are interested in Paxton Publishing's Spec-Bond Adult Education Solutions and our new releases, you will find our account executive's contact information on the screen. Thank you to COABE for providing these excellent sessions, and to Mark and Eric for today's session. Please look for information on upcoming COABE September 2018 events that will include some great offerings from Paxton Publishing. Thanks again. Now back to you, Michelle.
Thank you, Jane. Now today, our webinar presenters are Eric Appleton, who joined the CUNY Adult Literacy SHE Program Professional Development Team in 2014 as a math professional developer and the science professional development coordinator. Before coming to CUNY, he was a teacher and educational director at an education program for formerly incarcerated people called the Fortune Society. Eric is a founding member of the NYC Community of Adult Math Instructors and currently serves as the president-elect of ANN. Mark Truskowski started his adult education teaching career in a small basement classroom in Queens, New York in 2001. Since then, he has taught classes in adult basic education, adult numeracy, and the HSE math. Since 2009, Mark's work has focused on teacher training and curriculum development with the CUNY Adult Literacy and HSE PD team. Mark is a founding member of the NYC Community of Adult Math Instructors and was the lead writer for the CUNY SHE Math Curriculum Framework, Problem-Solving and Functions in Algebra. Mark serves as a regional representative and as a historian for the Adult Numeracy Network. And I'll turn it over to them.
Hi, everybody. Can you see my screen?
We can.
Okay, excellent. Well, so like Michelle said, my name is Mark. I want to thank COABE for having us and for Michelle for introducing us, and Jane and Paxton Publishing for sponsoring this event. And I want to thank all of you for spending a little bit of time in this sunny summer afternoon. I hope it's sunny where you are. As we're going to talk about sense making and answer getting in our math classrooms. So like Michelle said, Eric and I both taught reading and writing before we became math teachers. And I think for many of us who have taught reading and writing, we're comfortable generating discussions where students are using evidence from the text and using interpretation and making arguments. And it's understood by both students and by teachers that learning to read is about interpretation and analysis. But this isn't always true in mathematics. Often in math, students just want us to tell them the right answer or just tell them, how do I do it? So this is the issue that's at the heart of what we want to talk about today. In this workshop, we're going to share some strategies for opening up discussions about interpretation and refocusing on understanding instead of just getting the answer. Not that we don't want our students to be able to get the right answer, but we want to make sure that they understand what they are doing. A few quick logistical points before we start. We've already started. Many of you have been introducing yourselves in the chat. So we're going to be using the chat. We're going to try to make today as active as we can. So if you haven't already, just to break the ice, if you wouldn't mind introducing yourself in the chat, Eric and I are going to be looking through them just to get a sense of who's in the room with us. In addition, like I said, we're going to try to keep this as interactive as possible, balanced with the fact that this is a webinar and we have very limited time. So all of which is to say, you're probably going to want some paper and a pencil in hand. So if you don't have either of those things, now would be a good time to go and grab something. So we wanted to start off by sharing a few of the questions that have been guiding our exploration of this topic, this idea of sense making. How can we harness students' background knowledge and observations to build collective understanding within our class before they even make their first calculation, before they pick up their pencil and start doing what many of them consider to be the real math? How can we kind of broaden that doing of math? And how do we promote a close reading of mathematical texts? And how do we engage students who move quickly while also supporting students who need more time and engaging both of those students? The activities that we're going to be talking about today and modeling are some of the answers that we've come up with so far. These are obviously very big questions, so we're still working on it. So in reading instruction, one of our goals is to help students understand the story or whatever the text is that they're reading at that moment. But we also have this larger goal is we want them to be better readers. So to that end, we start with the question, what do good readers do? So take about 10 seconds and write an answer to that in the chat. What's something that a good reader does? What do good readers do? So obviously there's not one correct way to answer this question, but here's the list that Eric and I came up with. Good readers connect to prior knowledge. They generate questions. They visualize and create mental images. They're doing things. They're active as they're reading. They're making inferences. They're determining what's important. They're synthesizing information. And again, that active reading, they're monitoring their comprehension and applying if they read something and, oh, I didn't quite get that, let me go back. And they have strategies for fixing when they recognize that there's a gap in their comprehension. And they use a variety of strategies when they come against a text or a word even that they're unfamiliar with. So in helping our students, not just with the text in front of them, but all the text to come, these are some of the things that we're going to need to teach them. So all of these ways are ways that we keep active when we're reading. So what would the equivalent of this be in math? So I'm going to put another question out there. What do good mathematical sense makers do? So again, take about 10 seconds. I only gave you 9 seconds last time, but take about 10 seconds and in the chat and just put some ideas or what do good mathematical sense makers do? So again, there's not one right answer, and you can keep chatting, keep writing in the chat as I talk. But here's how we're kind of thinking about this. So it's the same list, it's the same idea. And for us, the only change here is changing words and text from problems, even though there are words and text in math. But we believe that it's actually important that our math students do all the same things that good readers do. These are metacognitive skills that are often missing from math classes. Certainly they were missing from ours, and they shouldn't be. And so that's part of our work, has been figuring out how to bridge that gap. Our students need to do each of these things to make sense of mathematical information. A quick shout out, you'll notice at the bottom of the screen, Annie Federer. She worked with the Math Forum. If you're unfamiliar with her work, Google search will send you on through a rabbit hole of a trove of treasures. But she gave a talk called Sense Making. It isn't just for literacy anymore. Really at the perfect time, Eric and I had been talking and thinking about these ideas, and kind of she helped us bring some of our ideas together, or figure out how to do that. So a shout out to her. So in this workshop, we're going to look at some ways to practice these skills, the things that are on your screen, while working in math. But before we do, let's remind ourselves while we're here and take a look at some student work. Sorry. So we're going to take a look at some student work. I'm going to put it up. So take about 2 minutes. Take 2 minutes to look at this work and respond in the chat in any way that you like. What do you notice? What are some things you see this student doing to make sense? Where do you notice that sense making breaking down? So let's take a couple of minutes in the chat and let us know what you notice. Okay, these are great. So keep going, but I'm noticing that you're noticing the same things that we noticed. For one, the student got the wrong answer, but that also, this is great. The student got the wrong answer doing exactly what we tell students to do, right? She did everything we asked of them. She identified and correctly identified the important information, right? This 35-year age difference, and she underlined it. She rewrote the important information on the side, 35-year difference between Paulina and her son, who's 8 years old. Rewrote the question, how old is Paulina? She showed her work, 35 minus 8 is 27. She checked her work, 27 plus 8 is 35. She subtracted because she showed the word, she saw the word, the keyword difference, and she told us that. She was able to express that. But does her answer make sense? So there's a 35-year age difference between Paulina and her son. Her son is 8. How old is Paulina? 27. Younger than the age difference between them. So an important takeaway, again, is that this student is doing everything they've been taught to do. They've been taught to look for keywords, to write down important information, show their work, check their work, but they're not thinking carefully about what the situation is or what their answers mean. Think about the equivalent of this in a reading class. Don't read that whole sentence, just read the most important word. Don't read that whole page, just read the most important sentence, and that'll give you the meaning of the whole sentence. So if your experience is anything like ours, you've seen a lot of student work like this. So how can we encourage students to prioritize sense making? And just to be clear, we're not saying that answer getting is bad or getting answers is bad. It's certainly not. But it is a problem when a student's emphasis on answer getting gets in the way of them understanding the problem, and especially when that leads to the wrong answer, which it often does. So one of the things Eric and I have been working on is how can we slow students down and get them to focus on what the problem means, what the situation is, before they start jumping into the calculation. So coming from a background of teaching reading, we have a useful structure that we were using in our reading classes. So activities that we do, they're things that we do before we read a text to help bring useful information into our working memory, to generate questions, to activate curiosity, interest, and background knowledge. And the things we do during reading to keep it active, to stay active and engaged, which include monitoring our understanding, addressing confusion as it comes up. And then finally, the third stage is after we read. What are the things we do? We reflect, we add perspective, and we develop an awareness of our process. So those, kind of using that structure, those three stages, we're proposing that same structure, but shifting it into our math classrooms. And so with that, I'm going to turn it over to Eric, and he's going to take us into our first stage. We're going to do some activities that could happen before problem solving.
Hi, everyone. This is Eric Appleton. Hi, everyone. This is Eric Appleton. I had myself muted, so okay. Hopefully everyone can hear me now. We'd like to actually do a quick poll. Michelle, if you could pull the poll up right now. While that comes up, everyone the question you can think about is, how much did you get paid per hour at your first job? So start to think about how much that was, and once you have an answer, go ahead and click and choose one of the 5 choices here, please. I'll give you about 30 seconds to respond. Michelle, do you have any advice if someone can't see the poll? Any suggestions on what they might do?
The only suggestion I would think would be to log out and log back in. For the most part, it looks like we've already had 172 people answer the poll, so
it might be hiding behind something too. That's yeah. Okay,
that's
thank you. Let's go ahead and close the poll and see what the results were. So take a second and look at these results here, and I'm curious to hear what you notice. What stands out to you about these results from this group? And while you're typing, one thing I notice is that it looks like the most common range of hourly wages in our first job was somewhere between $4 and $6. Mark, anything you notice about these results?
Sorry, I had to unmute myself. Well, I noticed a little bit of to kind of piggyback on what you said, the one in the middle is the one that's received the most. The 2 on either side of that are the second and third most, and then the 2 on the furthest out are the 4th and 5th most. So it's a little bit of a bell curve, though it's on its head.
Okay. Well, thank you, Michelle. I think we can close out and we'll go back. Mark, let's go ahead and go to the next screen here. So this question, how much did you get paid at your first job, is a question we've used in our classes. And so this example that you see right now is from a workshop that we did, actually. And you can see that students here, or participants here, responded with stickies rather than clicking digitally. And I wonder if you see any similarities in the data between what we just produced and this from this class. By the way, this graph is called a histogram. Histograms group data into intervals or clusters. So the clusters here are from 0 to 199, 2 to 399, etc. It's similar to a bar or column graph, but bars or column graphs show categories of data rather than intervals. But one thing to note if you were to use this with students, as a pre-problem solving activity, is it's nice to have a lot of data. And so if you have a small class, you might post it before class in the hallway. You might ask students to go collect data from other people in the building so that you have enough data to sort of see some trends and have some information to work with. Let's go ahead and go to the next slide, Mark. Another example of a pre-problem solving activity is making predictions from a title. The title here, the price of bread and the US federal minimum wage, is from a graph that we'll be looking at together. And so as a teacher, what I would do is share the title and then ask, well, I'm going to say that I'm going to show you some data that has this title. Based on the title, what do you think the data will show? What do you expect to see? Then we might ask students to talk in pairs, then share with the group. And what you're looking at are some notes from a board from a class and what students noticed. So they noticed that, this isn't what they noticed, sorry, this is what they predict based on this title. So they predict maybe both are going up. The price of bread is going up, the minimum wage is going up. Or some people thought the minimum wage might be flat and the price of bread is always going up. They talked about the range of the graph, that maybe it would start in the 1940s. Maybe that's when the federal minimum wage started. So we have other predictions about what the data might show based on just on the title. And this is related to an activity you might do in a reading class. Before reading a piece of text, you might just start with the title and to ask and brainstorm what you might see. The idea is that this helps students practice active reading and draws out their background knowledge and curiosity before jumping into the text, or in this case, jumping into problem solving. And so now we're going to actually look at that graph for this title. So this is a third activity. Basically, what do you notice is the question. Fairly straightforward. So I'm going to ask you to be a student right now. And to look at this graph, you have the title and you have part of the graph. What do you notice? I'm going to let you respond in the chat for a minute or two. And once you've shared one or two things yourself, you might want to scroll back and see what other people notice as well. So I'll just let people respond for a moment here. Notice some people are saying that there's no labels here. Green is increasing at a faster rate than the yellow. Which bar belongs to which? That's a great question, right? Which color represents which variable? Both are going up. You have to guess which is bread and which is wages. So my goal as a teacher at this point is to start drawing out what students are seeing and for students to benefit from each other's noticings. My basic tool for doing this is pretty simple. I ask students what they noticed and then I ask them to explain. If I were in a classroom, I would, we'd probably do a pair share first, but then as people share out as a group, I would ask them to point out things they noticed, but then I would follow up with a question. Basically, I would say, what do you see that makes you say that? Because oftentimes what people will share are inferences. So, for example, if someone says that the green is going up faster than the yellow, I want to know, what are they seeing that makes them say that? And I also want to know, does everyone else agree with that? Is it true that the green is going up faster than the yellow? A student might point out that the difference between the height of the yellow and the green is larger as it goes up, possibly, or as time goes by. But as another student might notice that the yellow is a larger portion of the green as time goes by. So there's different things that students will notice. But my goal here is to try and get them to provide that information and to draw out the inferences that people are making. I'm curious right now, does anyone have a guess on which of these columns represents the cost of bread and which represents the minimum wage? And if you do, I'm wondering if you can explain how you know that. Amy said that yellow is bread and green is money. But Brett said green is bread. So I'm wondering, is there some way to prove that one is the other or not? Okay, but we will have time to settle these questions. I'm going to pass this back to Mark to look at another activity.
Thank you, Eric. So I'm going, like Eric said, we're going to look at another before problem solving activity. We're still in that stage. So let me load it up for you here. So you've noticed, well, we've added in some numbers and a key. So please take a look, see how your predictions based on the numberless graph that we looked at, how they played out. But then what we'd like you to do is focus on that activity on the side there. In the chat, please write some true statements based on the data in this graph. And by true statement, we mean a statement that can be verified by someone looking at the information in the graph. And try to write a couple, maybe once you have written a few, read through the chat and see what other folks have written. You guys are doing a great job in the chat, engaging with each other, so you don't need any instruction on that. But take a few minutes and let's see some true statements. In 2010, the cost of bread is less than, oops, that went away. That went away so quick. There's so many statements. Sorry, Patty was saying in 2010, the cost of bread is less than half the minimum wage per hour. Interesting.
But Suzanne also said that bread is approaching half of the minimum wage.
Interesting.
A related statement. Bread cost has more than doubled from 1990 to 2010, but wages haven't.
So keep going. I'm going to add another representation, but of the same data. But keep going. Sometimes different representation helps people think about it in a different way. So keep going though, right? Keep writing these true statements. The minimum wage since 1940 has always been more than twice the cost of bread, says Holly. The minimum wage doubled from 1970 to 1980, something Lakshmi is offering.
Here's a nice point. I know the minimum wage is green because I've never seen a $7 loaf of bread. Unfortunately, I have seen a $7 loaf of bread. I live in Brooklyn.
City, unfortunately, it's bane of my existence.
May have bought one myself.
Emily says bread went from 10 cents to $3 in 80 years. So I'm going to talk a little bit. You can keep these coming in. But there are so many ways to use these statements in class, much more than we can discuss here. But our goal here is just the generation of these activities. Your creativity and ways that you can expand and use them is, I'm sure you're already thinking about it. But I just wanted to say one thing kind of in the context of our sense making. I just want, our role as teachers is to invite students to make these statements and observations and to help them verify those statements and the statements of their peers. Our job is to ask follow-up questions, help students go deeper into the stories to be found in each of these graphs and charts, and to be explicit in the way that they're making sense of the information. It can be very easy for any of the statements to just kind of step in and say, oh, this is true, and I can see that it's true, or this is not true, it's not precise. But the idea here is to turn that sense making, turn those things over to students, because those are the abilities they need to develop themselves, and the only way to develop them is to do it. It's like swimming. You got to get in the pool. You can't just you can't watch somebody swim. So we're going to stay with these ideas, the cost of bread and federal minimum wage, but I wanted to take a moment and stop, and because we're finishing our first phase, the before problem solving stage, and so I just wanted to go back and look at the activities we've done. We looked at a graph from student data. You guys did a poll, and then we showed you a photograph of an in-class lo-fi version. You did a prediction. You saw a prediction from the title. We looked at a numberless graph where you shared what you noticed, and then you wrote true statements. The first point I want to make is our goal is not that you use all of these activities, but it's that before problem solving is an important part of our lesson planning, and these are some activities you might choose from. You might just choose one of them. You might have others. But before we move on to the next stage of sense making, please take a minute to consider the activities that we've done in this before problem solving section, and just think about, did any of them encourage you to use any of the sense-making strategies that are on the right side of the screen? So please, if you have anything you'd like to share about your experience, please do so in the chat. We're going to continue, but please do weigh in as we go. All right, Eric, I'm going to turn it back to you.
Okay, so hi everyone again. So we're about to move into a during problem-solving phase. The before problem-solving activities that we've been working on previously have been leading up to the next activity. So we've sort of done our warm-up, and we're now ready to pose a central question to the class. So let's go ahead and take a look at that, Mark. So here is our central question. Based on the data above, when might people earning minimum wage have struggled the most? I'm going to give you a minute or two to think about that question and then start to respond in the chat. When you respond, see if you can collect some information, collect some analysis of either the graph or the table in order to give evidence to your answer. But go ahead and start. I'm curious about the answers that have multiple years, 1940, 2000, 2010. I'm curious about what's the reasoning? How do you approach this question? What are you thinking about when you decide when a time period might have been a struggle based on the data we have? One thing I'm noticing, Daisy is sharing that in 1940, 1/3 of wages was for bread. Is that something that you all see as well? What do you think about that idea? Here's an answer, 2000 and 2010, bread is closing in on the minimum wage. but is it because of the boutique bread and foods movement? Good question. Deborah says in 2010, bread was half the minimum wage and it would be hard to purchase other things. In 1940, they would have been struggling during the war. This was pulling in some background knowledge. I'm wondering if